Hi class, what I want to do in the next couple of minutes is to go over some concepts. I'm going to try to tie those via some reactions so you would be able to recall, for instance, balancing, how to write formulas, how you would name them, etc. Identify whether it's an ionic compound or not. And learn along the side whether there's redox chemistry going on or what. Or stoichiometry, and make your call as to how you can prep up some of the things that you have learned this semester. Realize your final is cumulative, so it's a good idea to start basic, pick a reaction, go from there. All right. So I have over here zinc reacting with HCl, and one of the things that happens in this reaction is that zinc is now going to start reacting with chlorine. So Cl, is with one negative charge, and zinc, that is one of your trustworthy elements, trustworthy metals. And so, like I discussed in the PowerPoints early on during the semester, you do your crisscross switch the charge trick, and your formula becomes ZnCl2. So the 2 that you had for zinc essentially is going to be the subscript for Cl, and what will that mean is that zinc chloride contains 2 chlorine atoms, and each of them is going to come with its own negative charge, and together they are going to counter for the 2 positive charges on zinc. So once you have zinc chloride, and it's really important to write down the correct formula, because if you don't write the correct formula, there's no way that you can balance your equation well. Realize that if now zinc is going to join hands with chlorine, that means it's going to free up hydrogen, and so hydrogen is going to go as a H2 gas. Hydrogen is a diatomic gas. That means it exists as 2 hydrogen atoms right next to each other. Another way to remember that: no fear for ice cold beer and hot peppers. Again, this is something I've discussed in the past. N2O2, F2, I2, Cl2, Br2, and hydrogen. These are all your diatomic gases. Okay, so hopefully you can see now that you need to put a 2 right in front of the HCl to balance this out. And now my equation is balanced. So stoichiometrically, if somebody asks you how many moles of HCl are required per mole of zinc, you should say that each zinc, when there's nothing, there's 1. Each zinc requires 2 moles of HCl, generates 1 mole of zinc 2 chloride and 1 of the hydrogen. And so consequently, if you're asked how many moles would 5 moles of zinc required, how many moles of HCl would be required by 5 moles of ZN. So realize that since the ratio of zinc and HCl is 1:2, that means that this should have 10 moles. And if you wanted to follow, step-by-step math, it's kind of common sense right now, but if you wanted to follow step-by-step, you would say, well, 5 moles of zinc, since each mole of zinc requires 2 moles of HCl, moles of zinc and moles of zinc cancel off, and that gives you 10 moles HCl. Couple more things. If somebody asks you what is the nature of this ZnCl2, is it covalent, is it ionic, or what's going on? Realize zinc is a metal, chlorine is a nonmetal, and anytime you have a metal nonmetal bond, that will pass for an ionic compound. So when you have to name it, you would simply look for the metal, that's zinc, and you're going to put in the anion as chloride, so it's chlorine, and so you drop the INE and you write it as chloride. Zinc is a transition metal, so a lot of times you would see it written as Zn2 chloride. However, zinc is one of those few transition metals that can be trusted, and so even if you see zinc chloride written as is without the Roman numeral 2, that's okay. On the other hand, if it was something like Fe, let's say you had FeCl2, you're going to call that iron 2 chloride, and you know that it's iron 2 because this 2 is the charge on iron and the 1 is the charge on chlorine, so it's iron 2 chloride. On the other hand, FeCl3 is going to be iron 3 chloride. So hopefully it's bringing back some of your memories from a long time ago. Well, not so long time ago, from chapter 2 and 3, periodic table and all that good stuff. Okay, let's talk about relative masses, and let's talk about molar masses. If you were expected to determine the molar mass of maybe zinc chloride, realize that the molar mass is nothing but the molecular mass expressed in grams per mole. And so what you will do is you would look at the periodic table, you would get the mass, which is the fraction number, so that's 65.5 on my periodic table, plus there are 2 chlorines, so 2 times 35.45, and simply work out the math and add them together, and it comes out to be 146.40 grams per mole. Realize if you would have written that as AMU, it would be called as molecular mass. If it's written as grams per mole, you would use the phrase molar mass to describe that. Now, if you were to determine, let's say, the mass of 2 moles of HCl, then of course you would first calculate the mass of HCl by itself and multiply that times 2 to get the relative mass for 2 moles of HCl. So hydrogen is 1, chlorine is 35.5, so that's 36.5, and that times 2, that will give you a total of 73 MU, or 73 grams per mole if everything was written in grams per mole as a molar mass. Let's work out a little bit of stoichiometry problem. Suppose the question is how many grams of hydrogen gas would be released when 2 moles of zinc undergoes reaction. So you know that this equation is balanced. We just balanced it. And so I can say that 1 mole of zinc gives you 1 mole of hydrogen gas. And so 2 moles is going to give you 2 moles of hydrogen gas. And so all you have to do is, once you have converted, figure out how much would the 2 moles of hydrogen gas weigh. And that's pretty simple. Since you have to determine for 2 moles of zinc, you would say that 1 mole of zinc, according to the balanced chemical equation, gives you 1 mole of the hydrogen gas. And since each mole of hydrogen gas is going to weigh 2 grams, the mole of hydrogen get canceled, and you end up getting 4 grams of hydrogen gas. Okay, let's talk about pH. So given a concentration, maybe you have 0.0015 molar HCl solution, and I want to determine pH of that. How would I do that? And then I want to run some in which I know the pH, maybe the pH is given to be 8.53, and I want to figure out the concentration of the H+. So how much would that be? let's take a look. Okay, so recall that pH is nothing but the negative log of the concentration. So the concentration is 0.0015, and so all you have to do is on your calculators find out the logarithm of log to the base 10 log of your number. So depending on your calculator, I mean a typical TI-30, what you will do is you will just type in, you would just punch in 0.0015 and then hit the log button, and that will give you a value. It will give you a number, negative 2.82, and so your pH comes out to be 2.82 as your final answer. Realize this number is less than 7, and so it should be acidic, and so it makes sense. Another way to look at it, those of you who are familiar with a little bit of math, a point that you can use to cross-check, realize this number is 0.0015. That means it can be written as 1.5 times 10 to the negative 3. And it is the law of logs that if anything is to the power, so it's in the exponent, essentially that's going to become you're going to have to multiply that. So you can write that this operation in math as negative 3 minus log of 1.5, and so it will be 3 minus a small number. So and your answer that you got is 2.82, so it does make sense. But if you didn't want to worry about, if you don't have much math background and you didn't want to worry about it and you just wanted to punch the numbers, all you have to do is put in your number that you have and then hit log, essentially, because pH by definition is negative logarithm of. You could also be given a pH, and you have to figure out the hydronium ion concentration. So since pH is negative log of the concentration, 8.53, log means it's to the base 10, and so one can say that you can multiply the both the sides of the equation by -1, and so the negative log or the negative sign would be given away, and so this can be written as log to the base 10 H plus is equal to minus 8.53, or 10 to the power of minus 8.53 is going to give you the H plus concentration. And so all you have to do in this one is you write down, you get this negative 8.53 on your calculator, and then hit second log, and that will basically find out the anti-log of the log operator, and so will give you the answer. In this case, that comes out to be 3 times 10 to the power of minus 9. So again, if you don't have a scientific calculator, you have to then, just try it out. One rule of thumb that I can tell you is that typical concentrations would usually be 1 times 10 to the power of minus 3, minus 9, minus 8, etc., whereas pH values are the ones that are written as as a number. So a pH of 10.5, we don't write it as 10.5 times 10 to the negative something. So it's not a small number. It's actually a fraction that will range between 0 and 14. Also realize that if the pH is between 0 and 6.99, that means we are talking about an acidic pH. pH of 7 means neutral, and anything more than 7 going all the way to 14 is going to be your basic pH. Alright, let's do some work on molarity, moles, etc. So you're given a formula, you have sodium nitrate. The question is, what is the total number of atoms in 5 moles of sodium nitrate? Realize if you would have had 1 mole of sodium nitrate, that would mean you have 1 sodium, 1 nitrogen, and 3 oxygens. That means you have a total of 5 atoms in 1 mole of the sodium nitrate. So per NaNO3 you're getting 5 atoms, and 1 mole means you have 5 times the 6.02 times 10 to the 23. And we are figuring out how much it is going to be for 5 moles of sodium nitrate, and so it will be another factor of 5. So on your calculator you would do you would say it would be 5 times 6.02 times 10 to the 23rd, and that comes out to be 1.505 times 10 to the power of 25. If you wanted to see that in dimensional analysis method from your first couple chapters, you can absolutely say that we have been given 5 moles of NaNO3, and 1 mole of NaNO3 will contain 6.02 times 10 to the 23 molecules of NaNO3, or units of NaNO3, however you want to call it, because it's ionic compound. And 1 NaNO3 unit contains 5 atoms total. We just calculated that. The molecules and molecules cancel, mole and mole cancel. Your math remains the same. 5 times 5 times 6.02 times 10 to the 23rd, which comes out to be 1.505 times 10 to the 25th. Let's also take a look at a conversion of grams to mole. Suppose you had about 15.5 grams of PCl5 and you have to figure out the moles of PCl5. How would you figure that out? Well, the first thing you should do is figure out the molar mass of PCl5. And so since you are given a mass 15 grams of PCl5 and 1 mole of PCl5 weighs, phosphorus is 31, each chlorine is going to bring 35.5, which all adds up to 188.5 grams per mole. 188.5 grams. And so your overall answer will be 15.5 divided by 188.5, which gives you 0.0822 moles of PCl5. Okay, I want to take your attention again to that zinc reaction we were discussing earlier. It was zinc plus 2HCl gives you ZnCl2 plus hydrogen gas. So if you think about it, zinc is becoming zinc ions. So in ZnCl2 you have, in a combined state, you have Zn2 plus, and you have H plus, which is becoming, let me change the color, H plus, which is becoming hydrogen gas. So it's becoming 0, no charge. It's going from +1 to 0 charge, and that can only happen by the gain of electrons. That means hydrogen is the one that's undergoing a reduction, and zinc is the one which is giving you the positively charged ion, so that must be losing electrons, and hence it would be oxidation. So LeO, which is loss of electron, is oxidation. The lion says grr. Gain of electrons is reduction. You must make sure that you know how to recognize a redox reaction and how you can tell what is going through reduction and what is going through oxidation. Realize that the species that itself goes through oxidation reduces materials around, hence it is referred to as the reducing agent. Likewise, the species that itself undergoes reduction oxidizes things around it and hence is called as an oxidizing agent. Typically, you would find most oxidizing agents amongst nonmetals, so towards the right side of the periodic table. And most metals will go through oxidation, and they are typically on the left side of the periodic table. Okay, when you are ready to figure out which particular electromagnetic radiation has maximum energy, so from chapter 3 again, realize there are various different kinds of electromagnetic radiations. You have the radio waves, you have the microwaves, you have the infrared rays, you have the visible region, you have the ultraviolet, you have the X-rays, and you have the gamma rays. So you can perhaps remember this as rabbits meet in very unique and expensive gardens, which stands for radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. These are in the sequence. Radio waves, as you can perhaps envision, is a part of telecommunication, so that's where your wavelengths are going to be high and energy is going to be low. On the other hand, gamma rays are your cosmic rays, so that's where energy is going to be higher, frequency is going to be high, wavelength is going to be low. So keeping that in mind, hopefully you can decipher that energy of any radiation is nothing but the Planck's constant times the frequency. So if the frequency is given, you can simply multiply that by the Planck's constant value and get your answer that way. On the other hand, if you were given a lambda value, then you can use the formula hc over lambda, because lambda times nu is equal to c. So realize that energy of any radiation is directly proportional to the frequency. So if you're given the frequency, simply multiply it by the value of the Planck's constant that would be given to you as well. Okay, another math-based concept that you would have seen would be in chapter on thermodynamics or thermochemistry, heat. And heat that is held by any body, Q, can be figured out by looking at the mass of that times the specific heat and the temperature difference between the initial and the final temperatures of what it was heated. So Q is equal to mc delta T. If you have, again, the mass of the material, the specific heat, or the temperature difference, the three things, when multiplied, will give you the heat associated by that body. So pretty straightforward formula, but I'm just reminding you of that. So this means if you were asked to figure out the amount of heat which is associated with heating maybe 20 grams of water, if it has to be heated from a temperature of 20 degrees Celsius to maybe 100 degrees Celsius, and realize that the specific heat of water is 1 calorie per gram per degree Celsius. So all you got to do is use the formula. So it's kind of like plug and chuck type of a situation. You have 20 grams, 1 calorie divided by grams times degree Celsius times 100 minus 20. That's going to give you 80 degrees Celsius. So degree Celsius cancels, gram and gram cancels, and you're going to end up with 20 times 80, which is 1600 calories, or you can call it 1.6 kilocalories. So whichever answer reflects that, that will be your choice. Let's spend a couple minutes in figuring out the molarity, which by definition is nothing but moles per liter. And so if you're given, let's say, something like, okay, maybe 24 grams of sodium chloride is dissolved in 250 milliliters of water. Or let's reword that a little bit. Okay, so 24 grams of sodium chloride is dissolved in water to form 250 milliliters solution. What is the molarity? Realize in a question like this, your solute, which is sodium chloride, and your solvent is water, you're basically looking for the moles of solute divided by the liters of the solution. Liters of solution can be figured out from the 250 milliliters. So all you got to do is divide that number by 1,000 to represent that answer in liters. And in order to convert the grams, you will have to convert it into moles. And in order to get that, you will first have to convert the 23 plus 35.5, which is 58.5 grams per mole. And so first you would say that you have 24 grams sodium chloride, and we are going to convert that into moles of sodium chloride. So 58.5 grams makes 1 mole. The grams and grams will cancel off. So on my calculator, I'm punching in 24 divided by 58.5, which gives you 0.410. So I had got 0.410 moles of NaCl. And now all you have to do is you have to divide this by 0.2500 liters to get your answer in molarity, and that comes out to be 1.64. So your answer for molarity is 1.64 molarity. So molarity is moles over liter of solution. And so you have basically learned two methods to calculate moles. One would be if you have the concentration and you know the volume, molarity times the volume will give you the moles. And another way to figure out the same thing would be the given mass divided by the molar mass. Both of these numbers will give you your moles. So let's do a final math-based question. The question is, how many grams of sodium hydroxide are required to prepare 300 milliliters of a 3 molar sodium hydroxide solution? So you're given the molarity, which is 3. You don't have any information about moles. You will be figuring that out. The volume that is given is 300 milliliters, or you can call it 0.3 liters, and that would mean 0.9 moles is what you got. So 3 moles per liter. Liter and liter will cancel off, and you would end up with 0.9 moles. Now, moles are nothing but given mass divided by molar mass. And since this is NaOH, sodium is 23, oxygen is 16, and hydrogen is 1, adds up to 40 grams per mole. So if you multiply the 0.9 times 40 gram per mole, mole and mole will cancel off, and you would end up with 3.6 grams. What this means is that if you take 3.6 grams of sodium hydroxide and you fill it with water such that the volume level marks at 300 milliliters, the concentration is going to be 3 molar for such a solution. This is not adjusted. This was just a recap of some math based questions, but of course we should go back to the previous tests, previous reviews, and prep up from there, previous quizzes, and prep up from there as well.